Hey everybody, welcome back. Tonight we're going to talk about berry development and the ripening process. So, an outline of what we're going to do tonight, we'll talk about a little bit anatomy, grape cluster and flower anatomy. Then we'll talk about berry formation and anthesis, pollination, fertilization, and fruit set. We'll also talk about the 3 stages of berry development and ripening and how to determine ripeness in tracking grape sample data. So the cycle of the grape, we did mention this earlier in class, but I do think it's important to say that most commercial grapevines are examples of perfect flowers. So the perfect flower is a flower that is self-pollinating, and that means it must contain both male and female organs. So AKA, it's a hermaphrodite. It's a perfect situation because it doesn't require any type of external factors for that plant to survive. So it doesn't require insects, doesn't require wind, doesn't require, anything besides itself in the right, climate conditions, of course. So it's the perfect flower. A little bit for the anatomy of this. We have what this looks like. This looks like a empty stem. Basically, like all the berries were removed. This is what it looks like before the grapevine flowers. So it'll actually develop the structure and all these little flowers at the end here attached to the pedicels of the stems. The main component is called the rachis here. So the whole kind of overall structure is the rachis. The major stem is called the peduncle, and then any kind of prominent branch coming off of the rachis is the shoulder. So those are the common terminology for that. And of course the flowers will be the little tiny buds at the bottom of that there. For the flower, we have both male and female parts, as we were saying. So we have the stamen, which contains the filament and the anther. So the anther is the pollen component. This looks a lot like fresh lilies pollen, and the filament is the little arm that holds it right into place there. So that's the stamen. Then we have the female components, which are the stigma, which will receive the pollen. We have the style and the ovary. Those are the female components that will turn from this kind of center green thing into a fertilized grape berry that will then become delicious wine. This is the nectary. These are odor glands that produce no nectar, ironically. So many Vitis species secrete odorous compounds, but Vitis vinifera seem to have no response to insects. So again, insects are not necessary for the fertilization of these flowers to become fruit. So that's just not really necessary. And then we have the pedicel, which is the attachment that holds everything together. So there's a little bit of anatomy. So let's just start at the very beginning of this whole process. We have spring, shoots are growing like crazy, and then these kind of rachis, all these other components form, and then we have these little tiny little buds. So first we have these little buds, and they're covered with this cap called the calyptra, or flower cap, and it protects the flower until it's ready to open and be ready for fertilization. So it will come off, it'll kind of peel off and look like this cute little hat, and then it'll pop off the top. And this contains 5 fused petals. Like we said, it protects the flower organs right before spring. So anthesis occurs 6 to 8 weeks after the beginnings of shoot growth. So it just depends on your region, depends on the variety, but in general 6 to 8 weeks. So here we go, we have the pedicel again, and then we have the beginnings of the filament showing, and also the ovary right here. So pretty cool. Once that pops off, anthesis is over, the flowers will open up, and the anthers will release pollen that is received by the stigma. That's not all. So once that happens, it can be 2 to 3 days while the pollen germinates on the stigma and then creates a pollen tube that works through the whole system and eventually reaches the ovule. And so then fertilization occurs and the berry begins to form. And grape clusters contain individual berries. So each one of those will have their own timing of fertilization, their own development. So they're not all going to be on the same page. And that's why we see a lot of variability in just a cluster with the sugar and acid levels. Of course, there is an optimum temperature for this process, and anywhere between 80 to 90 degrees is fantastic. Rain, cold, ice, snow, heaven forbid, will all affect this process very heavily. So after we've reached fertilization, we hit fruit set, and fruit set is determined as the stage when berry diameter is between 1.6 and 3.2 millimeters. So basically you start seeing semi, not super small, but semi-larger, little bit green berries. Interestingly enough, only 20 to 30% of flowers will develop into berries, so there's actually quite a few flowers compared to what becomes berries down the road on a cluster. So that's pretty interesting. There is something that can happen called berry shatter in grapevines, and this is when a flower doesn't turn into a berry and it falls off. So this can happen from the climate. It could be too cold or too hot. Rain, hail, etc. can cause this. So here we have a couple of really good pictures. This is from a fantastic article by Tablas Creek. If you don't follow them online, I would highly recommend it. They have been rated very highly as some of the best, most visited blogs for vintners, grape growers, and winemakers. Very informative, very well put together. But these are two pictures of their Grenache vineyards, or Grenache blocks. And what we have here on the left is a great example of a fully fertilized cluster. And then on the right, we see a cluster with lots of berry shatter. So you can see the leftover flowers are kind of falling apart. You can only see a couple of berries left on the cluster, and it's just looking very sad and very unhappy. So that's berry shatter. On the other side of the spectrum, after berry shatter, we can see some other problems in development, and that is called hens and chicks, which is a very old term, but a very popular term in the viticulture industry. And this describes the uneven pollination that can happen in vineyards in unideal spring conditions. So bad weather, if you have nutritional deficiencies, especially boron. So boron is one of the main nutrients that helps with like the growth and develop hormone in berries. So if you have a deficiency of boron in your vineyard, that could be a huge problem. If you have a viral infection in your vine, that could also be affecting its development as well. There's also a term for this in French, melandage, or Milan. I think they skipped the ER. I think it's melandage. Anyways, I don't speak French. Sorry, you'll have to Google it. There is another word for it. It might be on your quiz. Who knows? You'll find out. But there's a couple different definitions for this. So it's bunches that contain berries that differ greatly in size and maturity. And it could be small seedless berries amid normal berries. So pretty good definitions there. This is a great photo of what this looks like. So you can see we have some really nice large berries here that look like they're about to move into veraison, like start developing skin color. We're going to get into that in a couple slides. And then we have some kind of medium-sized berries in here. And then we have some super tiny, looks like completely undeveloped shot berries in here too. So this is a good example of hens and chicks, or chicks and hens, whatever you prefer. And this can affect the winemaking. So these smaller grapes will create sugars, but because they're smaller, you get less of a yield than if they were the full-size berry, of course. So it can affect your yields. You're producing less wine. And but some winemakers feel like it adds more complexity because of that too. And you also have to think about the skin to juice ratio. With smaller berries, you have a higher ratio of skin than juice, so it could bring some intensity to your wine. I've read that this is a really common situation for old clones of grape varieties, that this just happens very normally with those old clones. So some winemakers and some grape growers enjoy it, and some try to avoid it. So keep that in mind. Cool. So we have grape formation. Now let's cover a little bit of grape anatomy. So once fruit has set, the grape flower ovary develops into a fleshy berry. And then once that happens, the berry really develops into three main phases, which we'll talk about in the next slide. So for the berry itself, just to keep this relatively simple, we have the epidermis, which is the cuticle, the skin. the outer layer. And this is where all of the color comes from in wine. This is why we ferment on the skins. Unless you are a Teinturier variety, so if you are Alicante Bouschet or Ruby Cabernet, most all other Vitis vinifera species have a clear pulp. So Alicante Bouschet, like I said, it's a Teinturier variety, so when you crush open the grape, the juice and the pulp is also red in addition to the skin. It's a very fantastic variety. I really enjoy it. But for most other places, for most varieties, we have to extract color from the skin. So that is the epidermis / cuticle covering. Then we have the hypodermis. This is just under the epidermis, and it comprises of several cell layers. Then we have the mesocarp, which contains larger vacuoles comprising 85 to 87% of the berry's spherical volume. So that's the main component. Then we have the endocarp, which contains crystal-containing cells, sounds very fancy, called druses, and an inner epidermis. So this is the non-digestible coat that I was telling you guys about in previous lectures, that this is how plants have evolved to spread their seed. They create a fruit that looks and tastes appealing to an animal, whether it's a bear or a bird or whatever. They eat it, and then they eventually poop it out, and that's how that seed gets spread. And because it's coated in those indigestible compounds, those juices, it's able to survive the digestional tract of these creatures and then continue on and plant itself and have a new life, basically. Then we have the seeds, which have an outer seed coat, endosperm, and the embryo, which you don't have to know too much about that. If you're curious about the style / remnant scar, if you look at a cluster of grapes and you see a little cute dot exactly across the way from the pedicel, exactly across, right? So at the very outer part, that is just a scar from the flower cap, from the calyptra. So when this cap pops off, it creates a scar on the plant itself, and that's what's a remnant of that happening. So that's kind of cool. Awesome. Okay, so now we have our berry. How does that berry ripen? So there's 3 main stages, and here's a good graph. I'm going to have this all written out for you in the next slide. So this is a fun graph because it represents berry size and coloration, divvies up the stages in 1, 2, and 3, and it shows you the progression of the size of the berry, the color of the berry, and then in this blue line we have all the organic acids, the accumulation of those and the depletion, and also the accumulation of sugars. And then this word is highlighted because this is very important. I can guarantee it'll be on your quiz. Veraison is how we pronounce it in the United States. In France, they might say veraison or something like that. This is how it's spelled. A lot of folks just say veraison, though. So I know it's very confusing, but we will talk about that in the next slide. So stage 1, berry formation to lag phase. So very similar to how most species and most organisms on this world are created. The first thing that happens is cell division. So cell division will divide in the berry, but then acids and tannins will develop in the grape skin and pulp. So that's like when you bite into a piece of fruit, like straight off of a tree, that's extremely not even close to being ripe yet, and it just tastes super tart and horrible. That is what's happening. The acids and tannins are starting to develop in the skin, and it's not ready. So that is stage 1. So acids are peaking. We have cell division, cell division, and that's what we got for stage 1. No sugar yet. That's just stage 1. Stage 2 is a lag phase to veraison. So berries will reach half of their final size. Cell division stops, but they'll start to enlarge. So all the cells that will possibly be in that grape will be programmed and created by the end of stage 1. Stage 2, cell division stops, but they start to enlarge. So at this point, we're seeing, water intake, a little bit of sugar intake, and we'll get more acid and tannins, and then we'll reach peak acid content before veraison. So we will reach the maximum amount of acid that grape will ever see right before veraison. So let's just double check this here. So sorry, I lied. No more sugar. No sugars yet, not till stage 3. So yeah, a peak of acids. You'll see cell division stops, but the berry starts to enlarge, and that's stage 2. Everything is stage 2. Don't worry about these if you don't want. Well, you can if you want to. You don't have to know what all these mean, but we'll talk about flavor compounds. Cool. So stage 3 is marked by veraison. So veraison is the stage when the berries start to develop colors in the skins, they'll soften, they start to accumulate sugars, and they'll also start to metabolize acids. So this is kind of what I like to call the puberty of the grape. It's becoming into its adult form, it's becoming more expressive, it's developing its color, and its kind of final stage of evolution, if you want to compare it to Pokemon. So the grape will turn, for all of the black skin varieties or red varieties, depending if you're a Somm or not, they'll turn from green, it'll lose the greenness, it'll start to develop that beautiful purple hue, and it will continue to grow in size. The berry will swell with all the sugar accumulation from photosynthesis, and the acids will start to be consumed and the acids will start to drop. So that's the general situation there. Also in stage 3, we see glucose, fructose, or sugars, anthocyanins, and flavor compounds. We're going to talk about this in a couple slides, but this is engustment, the accumulation of flavor compounds and anthocyanins, and that's one of the last things to happen in the grape before it's harvested. So that's the ripening curve. Definitely get a good grip on what happens in each of the stages, and you should be good. And I also have an article here if you'd like to learn more. So with that being said, not every vintage it provides ideal growing conditions. So kind of like, this is another graph, and I'm sorry it's a little bit blurry, but these are optimal ripening conditions of a grape. So you'll see sugar accumulates, acids will drop, there'll be a ratio, an ideal ratio of sugar to acids, but then also flavor potential, that those engustment of flavor compounds will also reach a peak at some point too, before they start to give overripe flavors. And ideally, those all three come together on the same time and on the same day, and you have a picking crew ready and you can pick it and process it immediately. That's the most ideal world that you could possibly be in, but that's not the reality every vintage. So sometimes we reach a situation where the weather is bizarre on certain years and the climate is not ideal, whether it's too hot or too cold, and moving stuff around. And the sugar content will be out of balance with the acidity, leading to unbalanced fruit. We can make additions on the winemaking side. We can add water, we can add acid, we can reduce acid, but ultimately you can't make good wine without good fruit. And you're going to hear that a million times in this class, because this is the viticulture side of things. But it just creates an unideal situation, and I can guarantee you the wine would not be as good as if it was an ideal growing condition. So what can happen is in extreme warm conditions, the sugar will shoot up, the sugar will be way too high, acids will be too low, and the flavors of the grape will yield kind of dry fruit or prune-like flavors. So this can happen in hot regions like Lodi and sometimes Amador. Sometimes it's a slippery slope, and sometimes we let our fruit hang out too long and then we get those dried flavors, and sometimes that's on purpose. Sometimes that could be the style of the wine that the winemaker is trying to produce. For a long time, really big, hot Zinfandels, hot as in high alcohol, Zinfandels were all the rage in Amador County. That's what we were known for, was high alcohol fruit bombs, and I think the industry is kind of moving towards a different direction. For some of these wines now, we're going towards like lower alcohol. Some wineries are going no alcohol for future generations, health concerns. But so it really comes down to balance in wines and stylistic preference as well. But just depending on the maturity of the grape and these ratios, just development just changes every year. So that's why we keep track of Brix and pH, which we're going to talk about shortly, and everything else. We want to make sure that everything is within the right balance before we harvest this fruit. So we did talk about this in class, but again, it just goes with the presentation. So vine balance, the vine's priority is to reproduce and spread seed, not make perfectly balanced sugar to acid ratio fruit and fantastic wine. So dropping crop, also known as crop thinning, is done to balance the vine's ability to produce correctly. And this is typically done between fruit set to veraison. And then we said the veraison, of course, is when berries start to develop color in the skins. So this is a picture of Zinfandel at Boger. You can see that the berries are starting to turn purple. So we just went through and thinned that. And there's also an article from Grape Extension for you guys if you want to read more. So how do you determine when to pick? How do you sort through all this craziness? Keep a data log of all your grape samples. So just start sampling as soon as you feel like you might be getting kind of close. And once you have that data log together, you can try to find a trend in that data. So sugars should start climbing, acids should start dropping. And at some point, depending on the style of wine that you're trying to make, you should be able to come to a conclusion. Hey, I want to pick next week. Whatever kind of time frame you need to give your picking crew or whoever's helping you harvest in the vineyard, you have to give them notice, ideally, to do these big projects. So that's when you can try to predict the best time to harvest your grapes. And there's other things you have to take into account. Is it going to rain? Do I have help? Are we going to have a heat wave? There's some things you can do to kind of buffer these things. Like you can irrigate your vines and they'll actually take up the water and start to swell. And the bricks will go down for a little bit. But ultimately, this is one of the most stressful times for winemakers and grape growers, organizing in the mad rush. And when you live in an area where many wineries and vineyards are, it's kind of resources can be really slim for picking crews. We often share picking crews, and so it's whoever gets booked first, and it can be a huge headache. So it's a big thing. We already talked about berry sampling in class, but I feel like you guys have a good grip on what this is. If you have any questions on this, we can go over that, of course. So berry compositional factors. We talked about Brix and the sugar content in class, but there's also pH, seed maturity, and also the taste test as well. So for Brix, we talked about this. Brix will determine what your potential alcohol will be, or your final resulting alcohol. You can measure it with the pocket refractometer for juice samples only, but not fermenting less. It will also, based off of the Brix, you can try to harvest depending on the wine style you're trying to achieve. So sparkling wine is one of the earliest harvests, is very low sugar. Late harvest, of course, is one of the last to be harvested, if not the last. Then white wines, rosés, reds, these all have different alcohol contents, so they'll be harvested at different times in accordance to those styles of wine. So that's why Brix is so important to measure, as well as it being the maturity of the grapes and the best time for the best wine. So pH, on the other hand, that's where the sugar to acid ratio comes in. And on the winemaking side of this program, we talk about TA, which is titratable acidity. And I've never had vineyard owners measure that before, or at least not that I know of. So we're just going to stick with Brix and pH in this class. pH is a fairly representative measure of acid in a vineyard, but it's very important for winemakers to know too, because it represents the health and longevity of that juice, which will become wine. So if you don't remember pH, it's a logarithmic scale ranging from 1, which is highly acidic, to 14, which is highly basic, and 7 being neutral. And there's actually less than 1 and higher than 14 theoretically, but we're not going to be dealing with that in our scope of science in this class. So this will determine the health and longevity of the wine. Why does it matter for health? So everything that operates in our system, in the ocean, everywhere is based off of pH, right? So for example, like when you get an IV, right? An IV comes into your body and it has to be at an exact buffer, an exact saline solution for your body to absorb it, or it could kill you. pH of your fish tank, take a less dramatic example. Your fish, whether they're freshwater or saltwater, require the water in the tank to be a certain pH so the enzymes and all the positive and bad bacteria can thrive and they can live in their own environment. So just kind of like on a greater scale, we have that. And so on a smaller scale, when it comes to wine, our wine styles need to be within a certain range of pH for the yeast to appropriately ferment, for the bacteria that we want to thrive, to be healthy. If it's out of these ranges, the wine is highly susceptible to spoilage and just falling apart and potentially even making some people sick. What makes wine such a safe beverage to drink as far as, as far as bacteria or virus transfer is that the pH is so low that no human-borne pathogen can survive in it. But obviously it's toxic on the scale of if you overconsume alcohol as a toxic solution. So keep that in mind. Give and take. So that's why pH is important. Here we have just a nice picture scale for you guys. 1 is highly acidic, very toxic, very not safe for you to handle with your bare hands, as well as 14, very basic. Then we have 7, which is smack dab in the middle, neutral. And anything above 7 is slightly basic, also known as alkaline. Anything below 7 is slightly acidic. So we have mineral water. Wine ranges between wine can be anywhere from 2.9 to 4.0. So putting it on 4 is not really fair. Coca-Cola, also acidic. 3, your energy drinks, acidic. Pasta sauce, all these wonderful things. So just kind of to put a picture to the concept. Cool. So then determining ripeness by seed maturity. We did talk a little bit about this in class, but I love this picture. The reason why seed maturity is important is sometimes you might get hit with a really weird year of harvest or climate or whatever nature just throws at you, and your sugars might be way off and your acids may be way off any previous years of experience. Another tool that you can have in your belt is to look at the seed maturity. So seeds will turn from green to brown as they mature, and depending on the variety and what you're trying to pick, you can determine the maturity off of the seeds. So when I worked at a local winery, I used to do vineyard samples, and I determined the Brix, the pH, and the TA, because we're on the winemaking side. But then there's also a little note section where I was required to write about the color of the seeds. So were they mostly green? Were they partially brown? Were they mostly brown? Did they come off the pulp easily? So if they're ripe, they should come off of the pulp easily, and they should also be mostly brown. So this is important, especially on the winemaking side, because tannins come from seeds. They come from skins and seeds. So we ferment on these things with red wines. So if we were faced with a super hot season and sugar is just spiked, but the grapes were not developmentally ready on the tannin side, so the seeds are still really green, during that fermentation, we could be extracting really unripe, harsh tannins and even bitterness as well. So not ideal, very hard to work with down the road with a wine, trying to remove those things. So looking at the seeds is very important. Cool. Then we have picking by taste. Picking by taste is one of the old school way method of picking grapes. And there's a lot of logic to it and merit. So I'm not going to bash it, but it's just another way that you can determine when to harvest. So we talked a little bit earlier, we went through this graph. We talked about flavors, right? Anthocyanins and flavor compounds. So tannin, color, and flavor. So this is within stage 3. This is the last stage. That is called engustment. It's very important. It'll be on your quiz. Engustment is something you can taste. So tasting grapes can be a great way to understand when that happens. And we're not talking about flavors when grapes start to raisin and they start to become really strong and raisin flavors, overripe flavors, even cooked fruit or brown fruit flavors. That's not what we're talking about. We're talking about when the mature grape reaches its peak maturity or its prime, I guess, before it starts to deteriorate. So that's engustment. So some wine grape growers will choose to pick just completely off of taste. Lots of different types of viticulturists and winemakers out there. Okay, so last but not least, we have learning objectives. This will help get you guys ready for your quiz. No surprises, like I said. Once you go through these, you should be ready to take the quiz. And then I also have some resources here too. The pH is listed in the pH slide. But I did refer to a really nice PDF from UC Davis for this. And you can see I took some of the pictures from that as well. So I just wanted to give them credit where credit is due, of course. So if you want to do a more in-depth reading about all the stages and berry growth and development, I did cite this as one of my sources. And then also, of course, our new viticulture textbook by Jamie Good, chapter 7, page 111. So that covers berry development in the ripening process. I hope you learned something new. Good luck with the quiz, and I will see you guys in class.